All right, so today we're going to be doing a we do you do for dilations day 2. So let's take a look at number 1. A triangle has vertices J, K, and L. The triangle is dilated by a scale factor of 3. With the origin as the center of dilation, write the coordinates of J prime and an algebraic representation for this dilation. So I'm going to highlight my important information. I know it was dilated by a scale factor of 3. So now that I know what it's dilated by, I know what my scale factor is, I can write my algebraic representation. And we know we use arrow notation. So that's x comma y, arrow. And since our scale factor is 3, that means I'm going to multiply both my x and my y value by 3. So 3x comma 3y. Okay. Now in order to get j prime, first I have j, which is negative 3, 8. What I'm going to do is I'm going to multiply both my x value by 3 and my y value by 3. So negative 3 times 3 gives me 9, negative 9. Okay. And then I'm going to do 3 times 8. And that gives me my y value, and that's 24. So remember, this is your x, and this is your y. Okay. So I have my point of j prime, which is now negative 924 because we multiplied by a scale factor of 3. And since I multiply by a scale factor of 3, we know this is an enlargement. Now you're going to go ahead and complete A. Next, it says rectangle PQRS is dilated by a scale factor of 2/3. Write the algebraic equation needed to find the new vertices. So this one is really simple. All you're doing is writing the algebraic rule. So we know we have a scale factor of 2/3. So arrow notation, x comma y, 2/3 times x and 2/3 times y. And our scale factor is 2/3, so it's less than 1 but greater than 0, so we know this is a reduction. So now you're going to go ahead and answer letter B. Triangle ABC is dilated by the algebraic representation xy transforms into 3/2 x, 3/2 y. That's our algebraic rule. And so we want to decide if this is an enlargement or a reduction. And this, in fact, will be an enlargement. And it's an enlargement because 3/2 is the same thing as 1.5 or 1.5. Okay, so it's an enlargement because our scale factor is greater than 1. So because scale factor is greater than 1. All right, now let's take a look at number 4. It says determine the scale factor of the dilation. write the algebraic representation to represent the dilation. So I have triangle ABC and I have triangle A prime, B prime, C prime. So first and foremost, I know this is an enlargement because this is my pre-image and this is my image. So what happens here is we want to discover or find the scale factor. So in order for me to find the scale factor, I'm going to write down my coordinate pairs. So A is 2, 1. And then A prime is 6, 3. B is 5, 1. B prime is 15, 3. And last but not least, C is 3, 6. And C prime is 9, 18. So now that I know what my coordinate pairs are, I am going to figure out my scale factor. So what I'm going to do is I am going to take my new coordinate pair and put it over my old coordinate pair. So I can just take one value. So I can just take my x value because what happens to my x happens to my y. And so let's take A and A prime, for example. So I'm going to put A prime over A. Okay, so my x value for A prime is 6. So I put that at the top. And my x value for A is 2. So 6 divided by 2 is equal to 3. So that means my scale factor is 3. Since my scale factor is 3, my algebraic representation or algebraic arrow notation would be as follows. It's going to be x comma y, arrow 3x comma 3y. Okay, so in order to discover scale factor, you're going to go ahead and put your new value over your old value. And you should get the same thing because if I took B prime over B, that's 15 over 5, which gives us 3. And even if you took the Y value, that'd be 3 over 1, which still gives us 3. So this is an enlargement because our scale factor is greater than 1. You're go ahead and complete letter D, and then you're going to finish your Desmos activity for today. Have a good one.